Hi, Gloria. Hi, Joan. We got a task from you to analyze the data you guys provided to our team about customer churn. Here are our members of the team. Next page, please. My name is Chongbo Ma. We present the product in four parts, which are background, data processing, modeling, and conclusions. For my part, is data cleaning and backgrounds. For next page, please. Next next page, please. For the first one is the missing data. We found there are no new values of the independent variable and the dependent variable exists. Outliers processing is the second one. We found there is three outliers, the credit score, age, and normal products. But according to the business case, if the age is 19, this is normal number of products is categorical variable with maximum value of 4. So there is no need to try to match the business case. The third one is future engineering. We make the customer living make to 0 and 1, and we divided three countries, France, Spain, and Germany to two countries, to easier to make the models. Move to the fourth part is the future scaling. We make the value between 0 and 1 and standardize the range of the independent variables. In this case, we use minimax scaling. We use three models to analyze the data. Next page, please.
I'm Mingqu, and I will introduce the first model, logistic regression. It works on the principle that by learning from known data, it can predict the probability of an event occurring. We put coefficient, input feature, and bias into logistic regression formula, and then drive the value of y, which is the prediction of whether or not our customers will leave the bank. When the value is y is greater than the 0.5, the prediction is that the customer will not leave the bank, while the y is less than the 0.5, they will leave. They are explanatory variables, and the beta x1, beta x2, and so on are various variables in the data set, such as gender, age, and balance. But unfortunately, the false negative value is 365, which means that the bank incorrectly predicted those who will not leave, and actually those customers will leave, which made the bank not take any steps to attract them, which caused the direct loss to the bank. In this model, the best cutoff point is 0.25. At this point, the model has high prediction, recall is above average, and the F1 value is the highest, which represents the best balance of model precision and recall at this point. Then move to the lasso and the radius regularization. This step is to prevent overfitting. It helps to improve the generalization of the model to new data. It can also deal with handling multicollinearity. The normal logistic regression coefficients became unstable when the predicted values are highly correlated. Regularization helps to mitigate the issue by penalizing large coefficients. In this model, we find that the Germany has the highest churn rate because they have good service and the customers have more choice, so they are more likely to churn. Next, the value of cross validation is 0.79 on average, which means that this model has a 79% of correctly prediction customers who will leave the bank, and the standard deviation is very low, which shows that this model is stable. Then to the next model.
Hi, I'm Weihan Liao. Let me introduce the decision tree part. In this slide, the decision-making process of our model is being optimized. The formula is here about IA quantify the purity of classification at a node A, considering various customer attributes, and EA measures the uncertainty. Here, the Gini impurity index and the entropy equations lead us to the optimal slide for the excited attribute, improving our prediction of customer churn. The next slide, the next page. In this slide, the model has been presented where we arrived at the optimal configuration by testing every combination of parameters using an iterative approach with 86.85% accuracy. The example at 100 trees on concentrate depth and random state of 100. Therefore, this model exhibits great promise in terms of both high precision and generalization. It demonstrates the effectiveness of methodical machine learning tuning by ensuring that the model is not only a great fit to the data, but also a reliable model for future prediction or forecast. The next page. We can see the decision tree plot has been displayed, which clarifies our comparison of the Gini impurity and the entropy approach at an age threshold of 44.5 years and a product count of 2.5. The tree strongly bifurcates with a Gini score of 0.204, differentiating between 5,296 and 691 class instances. This segmentation clarity highlights the Gini method's effectiveness in our model. Let's move on to the next one.
Hi, I'm Evan Chen, and I'd like to share our journey in building the narrow network model. To begin, we started by importing pure precise data and modeling it with Python's default parameters. Through testing various parameters and read, the best hidden is 555 and the best read is 0.1. So we achieved an initial accuracy of 0.8. However, for this model, the F1 score is 0. It's indicating a lack of correct positive catalog predictions on the test data. So recognizing the need for improvement, our team implemented a threshold cutoff steps, which similar to what we did with logistic regression, and we use the best threshold 0.2. Please look at the model diagram on the right. Our neural network model consisted 3 hidden layers, and each housing 5 narration. Given the binary classification nature of our study, the output includes 2 values. The first one is churn, which means the customers leaving the bank, and the second one is non-churn, which means the customer staying. Next page, please. In this model, the F1 score is 0.33 and the accuracy is 0.19, which means that the performance of this model still have room for enhancement, and it can still save this from its loss curve. We observed a rapid interval drop, with reaching 0.5 only once, and the significant ups and downs. It shows a potentially higher learning rate. In summary, comparing with other 2 models, this neural network model doesn't perform very well. It still needs to optimize the learning rate for better stability and performance. Let's go to the conclusion.
Hello, Gloria. Here is the technical insights of the conclusion that we made based on the three modeling that we did. So that we think that decision tree is the best module based on the confusion matrix and as well as the accuracy score and the precision record and F1 score. So although you can see that in logistic regression model that the confusion matrix for true negative is the highest, meaning that it is the highest number of consumers that is going to maintain within the bank. But that when you compare the accuracy score, precision, and record score with the other like logistic regression model and artificial neural network module, you can see that the decision tree is the best performing one with the accuracy score of 0.844. So it means that it has a high accuracy percentage of correctly predicting the trained and non-trained bank consumers. Next page, please. So the technical insight to be continued is that we also analyzed the two other reasons that why decision tree is the best module. So the first reason is that although decision tree is likelihood to have the overfitting issue, but in this case, it might not be the case because it has a simplified tree structure of the three layers, including the parent node and the child tree nodes. And also it has a large sample size over 5,000, making it to fit with the criteria of minimizing overfitting issue. And the second one is that decision tree has the rule-based cutoff. For example, like when age is less than 44 years old and number of product is greater than 2, so that it's easier to be adapted and used for the business scenario than the numerical cutoff, like logistic regression and artificial neural network of 0.2 or 0.25. So the business insight is that Germany has more churning rates based on the logistic regression regularization coefficient, and it has a negative strong coefficient. And compared with the membership, it has a Germany has a strong positive coefficient and membership has a strong negative coefficient. So the suggestion is that Germany should encourage to have a localized consumer retention program and compare with the consumers in other geographical area like Paris and Spain to better explore why like consumer in Germany are more easier to leave the bank than other places. And to be secondly, a bank is encouraged to have the loyalty rewards for long-term membership to better increase the non-churning rate. So to be continued, also from the logistic regression regularization coefficient, the estimated salary also have a strong positive coefficient, meaning that when salary increases, the churning rate also decreases. So that's the bank is encouraged to have a premium banking service for the high salaried people, so that it will maintain more people within the bank, so that the revenue will also be increased. The second one is that's a little more tricky, is that balance has more balance increases, churning rate will increases. So that's balance it has a positive coefficient. It's that because when balance increases, people has more choices and they may choose to leave the bank and choose for the better service and the one that they prefer better or like the more popular one. So that bank should make an effort to have the higher balance benefits program or to compete with other bank with for the benefit program to just attract the consumers when they reach in high balance. And the last one is when a decision tree, these are the rules. So number of product when it's less than 2 and 44 years old last, it achieved the most number of consumers maintaining. And when it's the same age criteria, number of product is greater than 2, it achieved the least number of consumers maintaining. So the suggestion is that the number of product is the key, so that if you don't want to annoy your consumers to offering the useless number of products, so you have to simplify the banking product, make it useful, and at the same time, it is worth for having it. So that's all the presentation, and thank you very much for listening.